Okay, so let's look. Okay, yeah. So I'm also on Zoom, so this thing might pop up every now and then, which will be irritating. Sorry. Let me just close Zoom for now. Hold on. Okay, so now we're going to look at how we can differentiate functions. Okay, so let's say we have a function and we want to find the derivative of it. So let's just look at something very simple now. Let's just say, I'm going to define my variables again, even though I don't technically have to. Whoops. I do have to spell correctly, though. So this, and then we'll say, I'm going to call it function now. Doesn't matter. I'm going to call it function. And let's just give it a polynomial, test it out on something easy, x squared. And let's say I want to display the function just so I can make sure I have everything. Okay, and now I want to differentiate. So I'm going to say d function, so derivative of the function, sp.diff, and the syntax is pretty easy here, or maybe not easy, but it's reasonable. So I want to do expression, or sorry, function, and then the variable with respect to which I want to do the differentiation, which in this case is x. Oh, and then, whoops. Okay, so we know the answer should be 2x, okay, and that's exactly what we get. And for a function like this, we don't even need to do that. We don't even need to specify the variable because it's just x squared. Okay, so let's look at maybe a more exciting function. Let's do sp.cosine of x squared. So now we know the answer should be minus 2x sine of x squared. So let's run this. Okay, excellent. Now pprint is really stretching the word pretty. I would not call this pretty, but whatever, that's what it is. If we just want to look at print, I'm not sure what this will give us. I actually think this is a little bit better. So personal preference, I'm not going to pretty print that. Okay, I think this is better. Okay, another thing that we could do, we could use f strings. So I could say f of x equals func, right, like this. And when I run it, it'll give me this output here, like that. Okay, that's good. And maybe down here, I could write, again, use f strings, f prime of x equals like that. F prime of x is equal to this. Okay, so I think this looks better. Again, the double asterisks is a little strange, but whatever. Whatever you want to do is okay. So let's say I want to do something, even more complicated. sp.sine. So I'm going to have to kind of use multiple chain rules. Let me run it. Okay, I get this expression. Okay, but let's say I want to take the second derivative. Well, for that, I'm just going to put 2. I'm going to put the number 2 here, and it will know to take the second derivative. But notice there's a problem here, right? Because it's interpreting this 2 as the variable with respect to which we want to take the differentiation. So if you want to do something like this, you have to specify explicitly what the variable is. And I personally think it's a good habit to get into, just to always put the variable that you want to differentiate with respect to. And now when you run this, we'll get what we want. Okay, so that looks horrible. And just for the sake of doing painful things, let's compute the 20th derivative. So I think it might have just given up. So I was not expecting that. Okay, I think when it spits out the same thing that you gave it, it's not giving an error message, but it is just giving up. And now even the 4th derivative is taking a little bit too long. Okay, so I should have tried that before I made the video. So I'm going to pause the video for a second until this runs. Oh, nope, there we go. All right, so horrible, horrible, horrible. Okay. All right, so now what I want to do is, let's say we have a function of 2 variables. So sp.symbols y. So I'm going to say, let's say this is, let me make this a little less insane. So let's say it's x squared times, so cosine of x squared times y. And let's say we want to take the derivative with respect to y. So I'm going to put y here. And let's say we want to take the first derivative. So I'm going to put a 1 there. Okay, so what should it be? It should be minus sine of x squared times the derivative of that with respect to y. So it should be x squared. So the answer should be minus x squared sine of x squared times y, which is exactly what we get here. Again, so this is minus x squared, that's what that is, times sine. So that's what we get. But let's say we want to do the second derivative. So if I do the second derivative with respect to y, this is what I'm going to get. Okay, and let's say I want to do some mixed derivatives. So the first derivative with respect to y and the first derivative with respect to x. So this is the mixed partial derivatives. And when you run this, this is what you get. And, you make this 2. This would be the second derivative with respect to y. And sorry, the first derivative with respect to y and the second derivative with respect to x. I'm not sure what order it does the derivatives in. I think it does this one first and then that. If the function is well behaved enough, it won't matter which order it's done in. Okay, so this is an example of using Sympy to compute derivatives symbolically. So there you have it.